The electricity in your home comes from a power station. Power stations are these giant buildings where they burn a fuel like coal to generate electricity. So what they do is they open their door, they bring in the coal with these big trucks, which the coal comes from the mines, and here's the coal. They load it up into a furnace and they burn that coal. Through some really clever designing and inventions, you're able to convert that energy that's released, the heat, into electricity. So it involves something called a turbine, and the turbine spins and generates electricity. And then there's another thing you have to do, which is you use the heat, which is released from the coal. You use the heat to heat up water. So there's water in this pipe, and then the burnt coal heats up the water, which then turns to steam, and the steam goes out. It spins this turbine, and from there we get electricity. The electricity is carried by power lines to your home, where you turn on your light or your microwave or something like that. So this is how it works, very crudely. So we could write down the efficiency of this power station. We've got the power station. Here it is. And the power station, it's making a conversion here, right? We start out with the heat energy from the coal. That's our input. Heat from coal or whatever other fuel. You might be using natural gas, or in some designs, it's a nuclear power station, and that uses a different process for producing heat. So then the power station converts the heat from the fuel, right, this stuff here, like the pipes and the turbine, that converts heat into electricity. Like that. So there's efficiency, right, for the power station. Because you put more energy in here, the heat has more energy than the electricity has at the end. So you're losing some, there's some loss, and in fact you lose a lot. The amount you lose, typical efficiency for like a coal power station is somewhere around 30%. So you're losing about 70% of what you put in, which seems kind of high probably. So anyway, we're used to defining efficiency with work out over work in. But power stations produce power. So instead of talking about work, we could also define the efficiency as the power that you get out over the power that you put in. And remember, this is electricity, and this is the heat from the fuel. Electricity. Okay, so let's look at our notes. What do we know? We can use power to measure efficiency. And the equation is what we just wrote down, right? You're using power out over power in. In power stations, something is burned. Fuel is what we burn. But in the case of nuclear power stations, we react. They're like uranium to get the heat. This releases energy in the form of, it's heat that's released. So the heat is converted into electricity using steam in this clever device called a turbine. Alright, so take a moment, think about these questions, right? And then pause the video. Here are the answers, because you paused. What provides the input power? The fuel. And what's the output? The electricity. Alright, let's do a problem. A coal-fired power station generates 88 megawatts. Mega is 10 to the 6, but that's okay. We won't really worry about that. The efficiency is 34%. Find the power developed by burning the coal. This is the electricity. The power in the electricity. We want to find the power from the coal. So the equation is eta equals power out over power in. The output is the electricity. And we're looking for the input from the coal. right? So I'm going to take away eta and write down the percentage, but I have to convert it to a decimal first. So first I divide by 100. I have to multiply both sides by Pn to get it to go away on the right side. And why did I multiply? Because now it's in the numerator. And then I have to divide both sides by 0.34. Right, so I'm going to add 0.34 into the denominator. And I do 88 over 0.34, and what's that? 88 over 0.34. How many megawatts? Oops, 88 over 0.34 is 259 megawatts, we'll call it. So the power that the fuel releases is, what was it? 259. And the unit, remember, that we're left with, we're in units still of megawatts. That's how you solve these problems.